Okay, the lesson we're going to take a look at this week is section 1.2 and part of 1.3. We're going to do a little bit with the graphing calculators and just kind of figure out how to do what's called an intersection point, okay, where two things cross. That's the big thing in this section. All right, so the first thing they mention in 1.2 is just kind of a general problem-solving approach. It's not really anything specific or nothing that, it's just common sense. But just kind of a strategy anytime you're trying to solve any kind of problem, not just math stuff. So first thing is, anytime I give you a problem, you want to read it and try to identify two categories of things. What is he telling me in the problem, and what does he want me to find? Okay. If you can't figure out what the problem is asking you to find, like you read it, you don't even understand it, then you're going to have a hard time trying to figure out, well, what formula should I use? Because you're not even sure what they're asking. Okay? So read it, figure out what they're giving you to help, and then figure out what they want you to find. Now, the next thing you want to do is come up with a plan. All right? So for example, if I gave you the letters A, B, C, and I said, tell me all the different ways you can arrange those letters. Some of you might just start making a list. ABC, ACB, BAC, BCA, CAB, CBA. I think that's all. So 6 different ways. And I tried to list them in I tried to do them in alphabetical order, in a nice organized way. So you'd count them and say, oh, there's 6 ways. Well, that's fine for like a small number, but if I said, how about the letters A, B, C, D, E, F, G, and H? Tell me every way you can arrange them all. Making a list, probably not the best way to do it. How come? What would happen in that case? Yeah, Gary?
It'd just be like a lot.
Yeah, it could be like thousands or millions. So maybe making a list isn't always the best way. But that is one plan or approach you could take to solving some problems. What else do we do? Sometimes if you're given a lot of information in sentences, to make it easier to visualize all that information. We do it a lot in math. Yeah?
Like breaking into bullet points?
Okay, sometimes like people highlight things or like underline important things, but somehow just kind of identify important information. What else? Thinking of like another way to represent a lot of information in sentences. What else could you do that might make it easier? How about if you had a problem that said like, Joe's standing 200 feet away from a building. The building is 50 feet tall. What would be the angle he looks at if he's standing and he stares at the top, the very edge of the top of the roof? Like what would be a better way? And that's a lot of information in words.
Making a diagram. Yeah,
make a diagram, make a picture. So those are all different approaches you might take. Okay, sometimes making an equation and a picture go together. So you draw a picture, and then maybe if it involves a triangle, you're going to use a trigonometry formula from there. Okay, so sometimes you might use more than one of these. So you read the problem, figure out, okay, I think I'm going to draw a picture, and then step 3 is, okay, now I actually do it. Draw the picture. Label the information that you need to in the picture. Okay, so we're going to take a look at a word problem. I think you'll be able to figure it out. It's basic enough that it's more of like an Algebra 1 problem. But what I really want to do is come up with the formula and then use that to do some stuff on the calculator. Okay, so it's not a super hard word problem. All right, so our goal now is to come up with an equation for this situation. Company charges $15 to rent a car, and then 20 cents for every mile that you drive. Okay. So if you just reserve the car and you don't drive it, you're going to pay $15 just for reserving the car. And then if you drive it, 20 cents a mile. All right. So to set up an equation, I'm going to have numbers in it. Okay, these numbers are going to be in it somewhere. What else is going to be in my equation besides numbers? Yeah. Variables. Okay. And hold on, let me think. Is it Nakara? Nakara. So Nakara said we're going to have variables, and we are going to have variables too. Anybody think they could tell me what the two variables would be here? Yeah.
Could be like X and Y.
Okay, so we could use an X and a Y, and what are the two variables going to represent? Yeah.
The base price and then the amount per mile.
So we don't need variables for those because we know them. We know the amount per mile is 20 cents, and we know that the base price is 15. We need variables for things that we don't know. Yep.
How many miles you drive?
Yep.
How many cars you rent?
So we're just going to rent one car. So, but how many miles we drive that car is something we don't know, and that's going to affect the
Final price.
Yeah, the cost or the final price. So we're going to let y equal the total cost and x equal the number of miles driven. There's a reason why I'm letting cost be y and miles be x. And we'll get into that more later. But the idea is that the cost depends on how many miles. Cost is dependent on miles. Anything that is dependent is always a y variable. Okay? You don't walk into the rental car place and pick the cost. No, you can rent the car and drive it however far you need to. You can pick how many miles you're going to drive it, but the cost is going to be determined by how far you drive it. Okay? You pick how far you drive, the company tells you the cost. Right. So anyone think they could give me the equation? And it will start out as y equals. It's actually going to be an equation that I think somebody mentioned this format yesterday. I think Zach mentioned it. Yeah?
Y equals 0.2x plus 15.
0.2x plus 15. Yeah, that's y equals mx plus b. It's the equation of a line with a slope of 0.2. And what do you call this number at the end? This is your slope.
Y.
That's your y-intercept. Perfect. Any questions on that? Right. Now we're going to use that equation to figure out a couple things. So I'm calling it a model. It's an equation. It's a model that represents the word problem. So use your model, use your equation we just came up with to find the cost for 50 miles. So Brandon, what if I want to find the cost of 50 miles, what do I do with the 50?
You plug it into the x variable.
Yep, plug it in for the x. So y equals 0.2 times 50 plus 15. And then we'll write down the cost. 0.2 times 50. It's going to give me 10. Yep, 10 plus 15. The cost to rent the car is 20. Yeah, the cost is $25. Now, how about for 100 miles? Double the distance, should I just double the cost? 50? Why not? If I drive twice as far, shouldn't it cost twice as much? Zach?
35.
Why not 50?
Because everything isn't doubled.
Not everything is doubled, right? Only part that's doubled is this, the mileage part. You don't double the 15. That's like a one-time fee you pay to rent the car. Okay. So y equals 0.2 times 100 plus 15. Okay. So as Zach said, that comes out to $35. Okay. Any questions on that? All right. So what we came up with, that equation, that's called an algebraic representation of our problem. So if you see directions in the homework that say come up with an algebraic representation for this problem, it basically means write an equation. And since it's algebraic, it's going to have letters. So the idea is that if somebody walked in here right now and they read this, y equals 0.2x plus 15, they would have no idea that this is about renting a car. All they would see is an equation with a slope and a y-intercept. Okay? When you write an algebraic representation, you're kind of taking the word problem out of it. The word problem is gone. All you have is a pure equation. So, using the same example, same equation we just used, let's suppose that Sarah was charged $50 for renting the car. How many miles did she drive? A little different than what we did in the last two examples. What's different here? Yeah, Chris?
The y-intercept change to
The-
50?
The what?
The y-intercept change to 50?
Well, we're still using the same equation. So we're still using the equation with the y-intercept of 15. So that part's going to be the same. Yep.
Instead of trying to figure out, it's basically just giving you the total cost instead of you having like to do it the other way around.
Yes. Okay. So yeah, we're exactly right. You're finding the miles this time. You're not finding the cost. So where's that 50 going to go? Yep. It's going to go in for y. So we're going to solve this one two different ways. We're going to try it one way with just basic algebra 1 stuff, and then I'm going to show you how to do it on the calculator. So where I just circled, you're going to plug in 50, and then the rest of it stays the same. 50 equals 0.2x plus 15. Okay, Emily, what would be my first step, 2 out of 2, to get x by itself?
Subtract.
All right, so subtract 15. It's going to give me 35 equals 0.2x. And my last step, yep, Chris?
Divide 35 to 0.2.
Divide 35 by 0.2. And 35 divided by 0.2 is
17.5.
close. Your decimal is just off one.
17. Oh, sorry, no.
You did 35 divided by 2.
Yeah.
So you can divide it by 2 and then move your decimal one place.
10. No, wait, God dang it. Sorry. 0.2.
Yep, it's going to be 175. What's the label on that? Miles. Yes. Okay. So that's how you can solve it using algebra. Let's take a look at how we can do it on the calculator. So first thing we'll do is turn the calculator on, and we're going to go to y equals. If you have anything in there, you can just go ahead and clear it, so you don't have anything else. Okay. And I'm just going to copy down what we had up above. 50 equals 0.2x plus 15. All right, so what we're going to do is one side of this equation is going to be plugged into y1. The other side of the equation is going to be plugged into y2. Right? So it should look just like this. 50 in y1 and 0.2x plus 15. And you could do 0.2x, it's the same thing. 0.2. Now, we know that this is a line with a slope of 0.2 and a y-intercept of 15. This is also the equation of a line. Y equals 50. That's a special case where it's horizontal. So I want to find where the blue picture and the red picture equal each other. Well, usually we use the word equals with numbers. What does it mean what's a simpler way to say where the blue picture and the red picture equal each other? Where they do what? Yeah.
Intercept. intersect.
Where they intersect. So I'm going to press zoom 6. And I can see my calculator is doing something. The little yellow circle in the upper right is spinning. Still going. And now it's done. So one of two things. I either typed something in wrong, or what else could be happening here? Chris?
The graph is too small.
Yeah, my window is too small. It's off the screen. Does anyone have a suggestion for what I could start to do to adjust this? Either my X-min, my X-max, my Y-min, or my Y-max. Yeah.
I changed the X maximum to 60 and the minimum to 40.
X maximum to 60. Okay, and what else did you change?
The X minimum to 40.
40? Let's think about X in this case. What does X represent again? Miles. And what's the least number of miles you really could drive? 0. So what I would probably do is set the X min at 0. Doesn't make sense to have negative miles. But if you set it at 40, we might lose a little bit of information. But 0 technically would be the smallest. Right? Now, what's the most number of miles we can drive? Well, I don't know. I mean, infinite. You can make X max as high as you want. All right, let's hit graph. Still don't see anything. All right, what now? Any other thoughts? Yeah?
I changed the Y values.
Okay, what do you want to change those to?
60 for the maximum.
60 for the maximum? Okay. Now, how about the minimum? What's the, I mean, if you think of money, technically the smallest amount of money would be how much?
0.
0. In this case, it would actually be 15, because if you don't drive the car at all, you're still going to pay 15. But we could set it at 0. Definitely negative money doesn't make sense. Right, let's hit graph now. Okay. It's better. All right? So I told you that this was a horizontal line at 50. So you probably want to set your Y max a little higher. Don't put your Y max at 50. Then the blue line will be right on the very edge of the screen. 60 is good. But I'm looking for where these cross. So there's one value here you've got to make bigger to see more. Which value would I have to adjust? Make it bigger. Yeah.
Make X max like 200.
Yeah, I already actually know exactly what I need to do.
At least 175.
It's got to be at least 175. How would you know that before you solved it algebraically? You wouldn't. All right. If you were doing it on the calculator, you might do that and then say, okay, it's not big enough. I'll try a little bigger. So maybe you would try like 100 or 150. But it turns out if you go all the way to 200, that's going to be perfect. The point is you have to be able to see the intersection on the screen. Okay, now we're ready to find the intersection. So to find the intersection, you want to press second and then calc, and you'll see this menu. Now, anybody have a guess which option we're going to use?
5.
Yep, I'm going to use option 5. Okay, that's intersect. Now, there's 3 things you have to tell it to find the intersection. We only have a blue and a red line on the screen, but you could have a blue one, a red one, a green one, a yellow one, an orange one. You've got to tell the calculator which 2 you want to find the intersection between. Since we only have 2, it's kind of trivial. But you want to tell the calculator, all right, the first curve that I want to use is the blue one. I'm going to just hit enter. Now it's going to say, okay, you want to find where the blue one and which other one cross. Now it's on the red one. And I'm going to hit enter. Now it's asking me for a guess. For the guess, you can move it close to the intersection if you want. It actually doesn't matter where you put it. The reason it doesn't matter is because those 2 lines, in fact, any 2 lines, that aren't parallel. They only cross in one spot. Okay? The guess would matter if you had a problem like this. The calculator can only give you one intersection point at a time. So you have to tell it, okay, give me this one. So if you had a guess and you move the guess closer to here, the calculator would give you this point. If you move your guess closer to here, the calculator would give you that point. If you just put the guess anywhere random, it's just going to give you the one that it's closer to. So here, you can put the guess anywhere you want, because that's the only one. Okay? And then you hit enter, and it tells you the intersection is when x equals 175, which is exactly what we got. 175 miles. Okay. Questions on how we did that intersection? So we typed in each line, and then we went to second calc. Throughout this class, we'll use options 2 through 5. Not all today, but throughout the whole year, 2 through 5. 6 and 7 are calculus, so we won't be using those. And 1, we really don't need to use 1. We do what option 1 does, but we do it a little differently than using option 1. We use what's called a table, which we'll talk about later. Okay, so questions on that?
After you get first dot on the 2 lines, how did you get y2 equals?
How did I type in on line Y2? Right there? So I typed, to get down to line Y2, you just press the down arrow. I'm not sure if that's how you get to Y2. And then you can type in what you're looking for. And then you just do second, calc, intersect, pick a point. And it doesn't matter. I can tell I'm on the blue line, even though it looks kind of close, because the text is in blue. So pick a point somewhere on the blue. Pick a point anywhere on the red. And again, I can't really tell because it's so close, but the font is in red. That's how I know I'm on the red. And then my guess, you can put the guess anywhere you want. It does not matter. And then you get your intersection.
Yeah, the guess thing doesn't make sense.
The guess thing?
Yeah, why is it making a third dot?
Because of this.
Oh, it wants it to be like, which one are you specifically asking for?
Right. So if you had a problem like,
It had multiple intersections, you want to pick the closest one to the one you wanted?
yeah.
Okay.
So if you wanted all of them, you'd have to do this 1, 2, 3, 4 times. The calculator can't do all the intersections in one step. You'd have to do each one 4 times, just moving your guess. Yep. Okay, so when you have a viewing rectangle on the screen that shows you all the important features of your graph, now that's kind of vague. What's an important feature? Well, in our last problem, an important feature was an intersection. Not every graph has intersections, okay? But we wanted to see the intersection. If you find a window that shows you that, that's called a complete graph. All you have to do, if the book asks you to find a complete graph, is write down 4 things. Tell me the x-min, x-max, the y-min, and the y-max. So for the problem we just did, I would say 0 to 200 is good for your x-min max, and 0 to 60 is good for your y-min, y-max. Now, if you did 0 to 250, tell me, do you think, is that still a complete graph? Yeah, you can still see the intersection, that's fine. So what I'm trying to show you is that there's more than one answer. Okay? Any window that reasonably shows you all the important features of a graph. Now, if you did like 0 to 25,000, I would not say that that's a good graph.
Oh.
Okay, you set the x so high that the red almost looks like it's going straight up. And I can barely see the intersection. It's kind of hard to see. So that's not a good window. Right. But all you have to do is write down these 4 things for a complete graph. Okay, so let's graph a couple of things and just practice finding a complete graph. So we can get rid of the car word problem. We're done with that on the calculator. What I'm going to do between each problem is I'm going to press zoom 6. Remember, zoom 6 sets the window to a standard window. Does anybody remember what's the standard window? Negative what to what and negative what to what?
Negative 10 to 10.
Yep. Yep. It'll set everything back to negative 10 to 10. Okay. So let's try x squared plus 10. I'm going to clear x and y2. Zoom 6. Okay, the calculator is drawing something, and it's done. Is that a good window?
No.
No. If you can't see what you're doing, that's not a good window. This time, you only have to adjust one of these values. Anyone think they know which one you have to adjust? X min, X max, Y min, Y max. This is a parabola, but it's been shifted somewhere off the screen. But just in one direction. Go.
Go up.
Yep, so what would be a good value for Y max? Yeah, 20 would be good. If you did something like this, 10.5, you're just barely going to see the tip of the parabola like that. That's not a good window. Yeah, I'm starting to see the graph, but I can't tell that that's a parabola yet. If you set it towards x at like 20, that's perfect. Now I can definitely see that it's a parabola. So, an important feature of a parabola is to make sure you can see the minimum clearly. Or if it was flipped over, make sure you could see the maximum. So that graph we just drew, that's a parabola. And the general form of a parabola could look like this. I gave you one that was simpler. It was just x squared plus 10. But I could have given you like 3x squared plus 7x minus 8. Okay. So the equation that a parabola comes from is called a quadratic. The picture of a quadratic is a parabola. Let's try this one. The square root of x plus 20. Now, I want you to think about this for a second. When you take a square root, if you don't want to get an imaginary answer, what I just circled in red has to be what number or higher, so you don't get an imaginary answer. Is that?
Has to be 1 higher.
So, well, let's try 0.5. Let's see if we could take the square root of 0.5 square root. Yeah, so we can do 0.5.
So just above 0.
Close. Yep.
0 or higher?
0 or higher. You can also include 0. The square root of 0 is 0. So what I circled in red can never go below 0. It's got to be 0 or higher. Like try to plug in negative 22 for x. Right? Negative 22 plus 20 is negative 2. And then the square root of negative 2, it says non-real answer. Okay, so we're not worried about imaginary answers. So what does that mean x would have to be? If you never want what's under the square root to be a negative number, x would have to be, like you couldn't do negative 50. That wouldn't work. So what could you do? Yeah.
X min would have to be less than negative 20.
Less than negative, so like negative 100 would be okay?
No, like greater than.
Okay, so your x min is negative 20. You don't want to go any lower than negative 20. You go lower than negative 20, we have a problem, all right? Because you'd be taking the square root of a negative, and you can't do that. Yeah.
Or equal.
Yeah, you can equal negative 20. That's okay.
Okay.
So for x min, let's get rid of that. Negative 20 is the lowest you can go. So I might want to go negative 25 just so my graph isn't right on the edge of the screen. I always go a little extra, okay? That way you've got a little bit extra space. Now, how high could you go? Like, what's the highest number you can take the square root of? Infinity. You can really go as high as you want. So let's just go to like 200, and maybe that'll at least give us an idea of what it's going to look like. Now, if we plugged in 200 for x, what's 200 plus 20? It's 220. And then the square root of that would tell me how big y would be. So the square root of 220 is about 15. 15 times 15 is 225. So I don't think we're going to have to set our y max any bigger than like 15, 16, somewhere around there. All right, so let's set that at, actually 20 is fine. 15, 16, 20, that'll work. And now let's just type it in. Second, square root, x plus 20, and I'm going to hit graph. And you can see there's my square root. Notice that it doesn't go in the negative direction. It starts at negative 20. Negative 20 is right there. And it curves to the right. Okay. It's going to keep going to the right forever. It's also going to keep going up forever. It looks like it might be getting flat, but it never really gets flat. It keeps going up slower and slower and slower. But that's what a square root function looks like. Any questions on that? So we found a complete graph. Okay, we did it. So what do we write down? Let's just write down this. That was negative 25. X min, X max, Y min, Y max. That's all you have to write. Okay, yeah.
I just realized something. I tried downloading the calculator yesterday and Bulldog Draw did not work for a password.
Okay, let me, we'll take a look. Let me take a look at it. All right, so in that rent-a-car example that we did, that was our equation. I told you that the x and the y had different names. There's a reason why I said x was miles and y was cost. And that's because x is called the independent variable. Okay, that's your independent variable. It's what you're plugging in for. So it's also called the input. And another word they also use is domain. Now the y, that's your output. You plug something in, and then you get a result. That's your output, that's the y. That's called the dependent variable, or also the range. Okay, so just different terms for the same thing. So we've drawn lots of different pictures on the screen. We've drawn parabolas, we've drawn the square root thing, we've drawn some lines. I could also show you guys like a picture of a circle. We could draw a spiral. We can draw all kinds of things on the screen. Some things you draw on the screen are functions. Some things are not. They're all pictures, but some of them happen to be functions. Okay. And the idea of a function is that every x value has exactly one y value. If that's not true, then you just drew a picture of something that's not a function. Okay. So for example, let me draw a circle. All right. So let's say I go over here on the x-axis. Maybe this is 1, 2, and that's 3. When x is 3, what's my y value? Or how many options do I have for a y value? Yep. I have 2. When x is 3, I've got 1 point up here, And when x is 3, I've got another point down here. Did every x value have one y value? Not here. It had 2. So that means that this particular picture is not a function. Another way you might have learned is it fails the vertical line test. Okay, if you draw a vertical line, and I'm going to mention that at the very end. If you put a vertical line and it hits your graph more than once, not a function. Okay? So how about a parabola? Do you think that would be a function or not a function?
Function.
Yeah, function. Okay? Basically, passes the vertical line test. Okay? Square root, function. No matter where you put a vertical line, if you never hit it more than once. I kind of already said this to you when you wrote it down up above. But domain is what you are allowed to plug into a function. Range is the answer you get out. So, unless we say otherwise, the domain is always a real number. We're not worried about imaginary numbers right now. Okay, so domain is a real number. Now, when you write a function, there's 2 ways to do it. You can do y equals. That's how it looks on the calculator. Or you can also do this. Does anyone remember how you pronounce that? It's not f times x. It's not how you say it.
F of X.
F of x. Yep. So when we did the rent-a-car problem, we said y equals. You could have also done f of x equals. Okay, same thing. Just 2 different ways to write down a function. On the calculator, you got to use y equals. That's how it does it. Any questions on that? So a lot of problems throughout chapter 1 and into chapter 2 and 3 and 4, even 5, they're going to ask us to find the domain and the range of a function. When you have a function, notice here I wrote valid inputs. If you go back to the square root problem, wherever we did that one, not everything in the square root problem was valid. Remember, you guys told me -20 was as small as you could go. Because if you went smaller, you had the square root of a negative. You can't do that. So smaller than -20 wasn't valid. What if you had something like this? You cannot plug in any number you want for x there. There's one number you're not allowed to plug in for x. Every other number is okay. One number is not. You think they know? Yep. Right, x can't be 4, because if you did that, you would have 2 divided by 0. You can't divide by 0. So when you're looking to try to find the domain of a function, 2 things you have to watch out for. Don't ever plug in an x that would cause you to divide by 0. That's not a value you're allowed. And don't plug in an x that would cause you to take the square root of a negative. Those are the 2 big things. You've got to avoid square roots and negatives, and you have to avoid dividing by 0. So, let's look at this problem. Find the domain and the range. This is a square root. So yes, there's something we have to be careful about. You cannot take the square root of what kind of number? Negatives. So you're allowed to pick any x value you want, as long as when you plug it in, you don't get a negative answer. So anyone think they could tell me what values you are allowed for x here? Just pick x's that come out non-negative. So like for example, 1 is not a good x value. Can't use it. It's too small.
Anything that's 3 or above.
Yes, 3 or above. So there's 2 ways to say it. You can write it like this. That's an inequality notation. Or we can write it in what's called interval notation. You can pick any number from 3, and we put a bracket on it. Bracket means you can include it. Up to, so the 3 is the low, and now we're putting in the highest value. Well, there is no highest value. You can pick any number from 3 up to infinity. The bracket on 3 means you can include it. We put a parenthesis on infinity because you can never include infinity. You can't reach it. Okay. So these 2 things mean the same thing. Now if you did this, parentheses, that would mean this. If you wanted to say x is any number bigger than 3, that's incorrect for this problem. But if you wanted to write that, that's how you would do it. We want that. Now, to find the range, that's how high and low the graph goes. Domain is left and right. Range is up and down. Let's graph it, the square root of x minus 3, and see what it looks like. Second square root, x minus 3. I'm going to do zoom 6. Okay, I know what a square root function is supposed to look like. It starts and it curves in one direction. I can tell which way it's curving. So it's going from 3, and it's going right forever. Now, how about up and down? What's the lowest that it looks like this graph goes?
0.
Yep, 0. And how about the highest?
Infinite.
Yeah, infinite. It's just going to keep going up. So you can say the range is any number greater than or equal to 0, or you can write it like this. That's your low value, that's your high value. So the lowest it goes is 0, including 0, it does hit it, and the highest it goes is infinity. Okay, so the calculator is helpful to find the range. Sometimes when you get better at it, you don't need the calculator, but even some complicated ones, I still need to look at it because it's complicated. Okay, we'll try, I think I'm going to skip this one, but I'm going to do the next one. So we're going to go right to B. I want to do B because B is almost the same as A, except B has absolute values. And I haven't shown you, I don't think yet, where absolute value is on the calculator. Okay, so same directions, find the domain and the range. So the 2 things I said you got to be careful about with domain. You never want to take the square root of a negative. Are there any square roots in this problem?
No.
No square roots, so we don't have to worry about that. And you never want to divide by 0. Are there any fractions in this problem with variables in the bottom?
Nope.
No. So the 2 things I said to be careful of are not in this problem. So all you have to ask yourself is, what number or what numbers are you allowed to raise to the second power? That's your domain. What numbers are you allowed to square?
All real numbers.
Any number. You can take any number you want and square it. So the domain at its lowest is negative infinity, and its highest, positive infinity. Another way to write that is to write all real numbers. It's the same thing. Now the range. This is where the calculator helps. All right, so absolute value. You got to press 3 things. Math, number, and then option 1. That's where absolute value is. It's math, go over to number, and pick option 1. And it puts the absolute value bars right on the screen for you, and you can start typing right in. X squared minus 4. And I'm going to do zoom 6, and we'll see if that's a good window. Yep, looks good. What does it look like the lowest that that graph ever goes is?
0.
Yep, and the highest?
Infinity.
Infinity. Yep. 0 to infinity. In fact, it hits 0 in 2 spots. It hits it at 2. Try plugging in 2 for x and see what you get. And it hits it at -2. Plug in -2 for x and see what you get. You get 0. Any questions on that? Yep. So to do absolute value, it's under math, number, and the first option, ABS, annual operations. You press that, and then you can type in, I'm not in the y equals screen, but if I was, now I could type in x squared plus 4 or whatever it was, minus 4. Okay, so second to last thing, evaluating. Basically, that just means I give you a number, you plug it in. That's all that evaluate means. I give you something, and you plug it into the formula. I'll tell you the formula. I'll tell you what I want you to plug in. You just have to do it. So there's our formula. X squared plus 1. Right, let's plug in -2. So remember, you'd pronounce that f of -2. The long way is basically to say, what is the value of the function if I plug -2 in for x? Tell me what y would come out to. So, if you plug in -2 for x, what would you get? Yep.
5.
Yep. -2 squared is 4. 4 plus 1 gives me 5. Well, let's try another one. What if you plug in 3 for x? Zach?
10.
Yep, you get 10. How about if you plug in a for x? What would you get now? And don't overthink it, just literally plug in a for x, and that's all you can do. Yeah? A squared plus 1. And let's do one more. Let's plug in x minus 3 for x. I ran out of space, but if you have more room, you could put this right next to the other 3. So that would be x minus 3 squared plus 1. Now that x minus 3 squared you can simplify, but you have to remember, it means this. How do you do this out? X minus 3 times x minus 3. Sometimes there's a word people use to remember it.
Foil.
Yeah, this is like FOIL. X times x. What's x times -3? Yep, and another x times -3. So a -3x and another -3x. It's a -6x. And what's -3 times -3? 9 plus 1, 10. So a little more complicated because you had to plug in and FOIL. It's a little more complicated than just plugging in a number like 3. But as long as you know how to FOIL, you're good. Any questions on that one? Okay. All right, so last thing. And I already mentioned part of this to you, not every equation is a function. Okay? If I were to graph, I don't think I graphed this one yet. It's a square root function, but it's 2 halves of it. Okay? So you guys have seen what this looks like. Let me also graph this. This kind of came up in the homework when you did the distance problem and you had to do the positive and -6 to get both square roots. That's kind of what we're looking at. Okay, there's the positive. Now watch the negative. That's not a function. Not a function. Because when x is, I don't know, 3, I could be here or here. Each x value doesn't have just one y value, it has 2. That's a problem. So visually, the quick way to tell is to do that. If you can put a vertical line and it hits your graph more than once, you do not have a function. Okay, that's called the vertical line test. If you draw a vertical line anywhere and it hits your graph more than once, you do not have a function. What if it only hits it once? Then you do have a function. You're good. Okay, and that's called the vertical line test. Okay, so I'll put up the homework and then I'll kind of summarize what you want to make sure you focus on for the test tomorrow. So the homework, it'll be 2 pages because we did 1.2 and we did part of 1.3. Did everybody have that? Okay. I think there's like 10 or 11 problems from each page roughly. So page 20, 6 through 10. And then 18, 21, 29, 32, 38. Okay. And then page 30. 3 through 8. 11, 13, 16 to 19, and 24. Alright, so the test tomorrow. Alright, so things you want to make sure you know how to do. Graph on a number line. That means the open circle, closed circle, bracket, parenthesis stuff. You should know how to evaluate absolute value. So if I said, like, what's the absolute value of -7? 7, right? You should know how to do simple absolute value problems. Distance formula. That's the formula that's based on Pythagorean theorem. Midpoint formula. What other kind of stuff? Okay, set a viewing window. The way I would test you on that is I would say, here's a formula, type this into your calculator, set your x min to 5, your x max to 20, your y min, your y max, hit graph. I'll give you pictures on the test of which one it should match up to on your screen. Okay, so you have to know how to set the window. Okay, evaluate, that's what we just did. Evaluate a function. That's like plugging in a number and telling me what you get. Finding domain of a function. So make sure you definitely be careful about dividing by 0 and square roots. Those are the 2 things to focus on. Don't divide by 0. No square roots of negatives. Those are the 2 important things. So domain, we also did range. Remember, domain is left to right. Range, that's how high and low your graph goes, up and down. And then determine if something is a function. Determine if a function. Okay, how do you do that? That's where you use the vertical line test. Okay, so those are all the topics that are on tomorrow's test. It'll be a mixture of some multiple choice and some short answer. And it'll probably be about 15, 16 questions. Okay. Also, because of the back to school night, I don't know if I mentioned it yesterday, I just remembered in the afternoon. I have to be back here at 5 o'clock. So as far as extra help, now would probably be the best time if you have something you want to ask me. You still got about 10 minutes. Ask me anything you want to know, especially about the calculator, because I'll answer calculator questions tomorrow before the test, but not during the test. So anything you want to know, you got about 10 minutes right now to ask me about.